So before we get into any question, I wanna do a review about like all the equation. So the PA exercise are actually the suggested problem like in your, I think your prof posted them like from last week. I can show you. So they are actually over here. And like after the section, I'm gonna post the recording PA and also like all the solution. So for the question there, you can go to your main course. And in week 1, go in down to here, the suggested problems. So those are the questions we're gonna cover today. Oh, if you're talking about the PA exercise like we had in Ecor1047, we don't have that. Like for this one, we're just gonna go over those questions. Okay, so we can do a brief review about the dynamic. So we know in this course, we're gonna mainly deal with 3 physical components. So first one is a position, and like I usually use S or sometimes X for that. And the second one is the velocity. So for this one is just V, velocity. And the third one is acceleration. And that is A for acceleration. And like usually from position to velocity, and also from velocity to acceleration, also from position to acceleration, we're gonna do the differentiation, like finding the derivative. So this one gonna be derivative. And if you wanna going back, like from acceleration to velocity, from velocity to position, and also acceleration to position, we're gonna do the integration. So those are about the theory, and we go to the equation. So usually first one we have is the velocity. Remember velocity is the position doing the differentiation. So it's gonna be ds over dt. And the same thing for the acceleration. So a is gonna be dv over dt. And another one, like usually, we're gonna use them like in today's question, is a function or like a formula called the ADS is equal to VDV. So like usually for those equations, you just need to memorize them or like know they actually exist. You don't have to, also like you don't have to understand like how to derive those equations. Like you just need to know how to use them. So for the other way, like we're gonna have the position or like yeah, position is gonna be doing the integration from one value to another value of the s. So that is gonna be deriving from 0 to t v dt. Like we're just going to do like a reverse a calculation of about this formula. And also we're gonna do the same for the acceleration, I mean the velocity. So velocity gonna be equal to, we're deriving from 0 second to t second of the acceleration dt. And actually this one feels a bit confusing, so like this. And for the third line, gonna be the same. ADS is equal to from one velocity to another velocity of VDV. So those are going to be the equation. We're going to use them a lot in today's PA section and maybe like in this course. So like for those, the acceleration A can be like a variable, like it doesn't need to be a constant, but like I'm gonna write it down, can be a variable. But if you guys remember, like in a high school, we learned some dynamic equation as well, like velocity is equal to displacement over time. And also the final velocity gonna be equal to the initial velocity plus the acceleration times time. And also the displacement is equal to the initial velocity times time plus half acceleration times time to the power of 2. And another one is the final velocity, the square root of final velocity, I mean minus the initial velocity to the power of 2 is equal to 2 times acceleration times displacement. So those equations like we learned from the high school, they're actually for the acceleration when the acceleration is a constant. So those for acceleration is a constant. Okay, so we have the formula we're gonna use, and now like every time you have a question, you wanna see if the acceleration is a constant or not. If the acceleration is a constant, maybe you can just use those equation from the high school. It's gonna be easier to find the answer for like solve the problem. But if the acceleration is not a constant, we're gonna use those like some new equation like the derivative or the integration to solve the question. So I'm gonna finish this one. So variation can be a variable. Okay, so those are the bit of the review. I'm gonna move them. I'm gonna put them down. Then we can go to our first question. So the first question, I'm just gonna draw a diagram about what's gonna happen. So we have a train starting at station 1, I mean station A, and the first segment is gonna be, I'm gonna put it like 1. So in this time, the acceleration is a constant that is equal to 0.5 meter per second square, and the time is 60 seconds. So it's T1 or like A1. And when it reach the point on here, the train gonna be moving as using a constant speed. So the velocity, we don't know like how fast is it, but like we know it's gonna be a constant. So it's constant, and that's gonna take 15 minutes. So once they reach here, it's gonna slow down. Oops. So the third one, the train is actually gonna go into station B. And in this time, the acceleration is gonna be -1 meter per second square. So those are gonna be like what's happening for this question. And we're going to calculate the distance between the stations. So we're gonna calculate like what's gonna be the S between A and B. So for like I'm just gonna calculate the S1 and S2 and S3. 2 and S3. So for the S1, like we know the acceleration is a constant and we know the time. So for this one, we're just gonna use the equation like we learned from the high school. So that is the displacement is equal to the initial speed times the time t plus half acceleration t to the power of 2. And in this case, we know the train like starting from the rest. So the initial velocity is going to be 0. So I have a 0 here. And only thing left is half times the acceleration. We know the acceleration is 0.5 meter per second square and times t square. So t is 60 seconds. So it's going to be like this. And then just use a calculator to do that. And eventually we're gonna get 900 meter. So that's the displacement from A to the point over here, the S1. And next step, we're gonna calculate S2. So that is S1. For S2, like it's just like moving in a constant speed. So we just like first we wanna find out how fast, like what's the speed of the aircraft. I mean, the train. So we want to say the VT, like the final speed of the train, is equal to the initial speed at point A plus the acceleration times the time t. So just like before, we know the acceleration is 0. So only thing left is the acceleration 0.5 times the time t. Actually, I say t1 times 60. So that is gonna be 30 meters per second. So that means the train, when the train reach the point over here, it's gonna move at 30 meters per second for 15 minutes. So now we have the time, we have the velocity. It's gonna be easy. So S2 is gonna be equal to the speed times the distance. I mean the speed times the time. So gonna be V2 times T2. And that is 30 times 15 minutes, and 1 minute is 60 seconds. So that is going to be 27,000 meters. So that is the first segment and the second segment. And let's go to the last one. So for the last one, let's see what we have. Like, we don't have the time. So like t, we have no idea what's going to be the t. But what we have is, we know the velocity at b is 0, because like it's going to stop at b. So the velocity at b is 0. And we also know the velocity here. Like maybe I'll say it's v2. You already calculate that. So that is 30 meters per second. So now we have the initial velocity. We have the final velocity. We also have the acceleration. And we're looking for the displacement s. So going back to our equation, there's actually a easier way to do that. Gonna be this one. Like, we know the final velocity, we know the initial velocity, and we also know the acceleration. And this is the only thing we're looking for. So I'm gonna use this equation to do that. So I'm gonna repeat the equation. The final velocity minus the initial velocity is equal to 2as. The final velocity is 0. Actually, I'm gonna keep in the same number. So it's gonna be VB minus V2. So it's gonna be 0 minus 30 to the 2 is equal to 2 times deceleration, because it's decelerating. So it's a negative value. So times -1 times the value we're looking for, s. S3. So we have S3 is equal to, like, moving this one to the left hand side and like swap them. So it's going to be -30 to the power of 2 over -2. So that is going to be 450 meters. Okay, so we have S1, S2, and S3. And the total distance from station A to station B is just going to be the sum of them. That is going to be 900 plus 27,000 plus 150. And it's going to be 28,350 meters. So that is for the first question. Guys all good on that? Okay, so now let's go to the second question. So we have a train again, it's moving in this speed. And also we know t is in seconds. And we are going to determine the distance traveling in 3 seconds, like t equal to 3, and the acceleration at this time. So just write down what we know. So velocity is a function of time now. The unit is feet per second. And we're looking to the displacement in t equal to 3 seconds and the acceleration in t equal to 3 seconds. So in this equation, like it's actually given a function between velocity and the time. So if we try to use like the equation we learned from the high school, it's gonna be kind of hard because we're not sure like if we're not sure the acceleration is a constant or not, and also we're giving a equation like a relationship. So we're gonna use the new equation we learned from this class. So like from the first one, like we wanna find out the displacement s. So for s, finding the s, like going back to what we have on here. So we know s is actually the from velocity to s, we are doing the integration. So we're gonna use this equation. Like the velocity is a known value and the s is the thing we're looking for. So this equation, like for this equation, we have everything we know, and also like we know the time is from 0 to t. So that's the equation we're gonna use. So s is equal to from the, let's see, gonna be from 0 second to 3 seconds, because it's actually written on here in 3 seconds. And what we have is VDT. And that is going to be equal to 60 bracket 1 minus e to the power of negative t and dt. So what we have to do here is going to solve this one, solve the integral. And I guess you guys know how to do that from last year, your math 104 class, 1004 class. So like for the math, I'm just gonna do it very quick. So that is gonna be 60t plus 60 e to the negative t. And we're going to evaluating from 0 to 3. So just put in a number is 60 times 3 plus 60 e to the power of negative 3 minus 60 times 0 minus 60 times e to the power of 0. So that is 60 to the negative 3 and minus this one goes to 0 and the other one is 60. So the solution gonna be 122.98 feet. So that is how we find the displacement s, just using this formula. And the next one is finding the acceleration. So it's gonna be pretty similar. For the acceleration, it's gonna be the derivative of velocity over time. So a is equal to dv over dt. And essentially, we're just going to do 60. Just plug in the value for velocity 1 minus e to the negative t dt. So just gonna find out the derivative of this function over t. So that is 60 dt minus 60 e to the power of negative t dt. So 60 dt is going to be 0. And negative 60 e to the power of t is going to be plus 60 e to the power of t, because it's like this one, we can have a -1 to the front and a -1 cancel with the -1 on here. So they're gonna become a positive sign. So we have a positive 60. And then like everything remains the same here. Guess it's a bit of the chain rule, but assume you guys all remember them from last year math class. So what we have is just 60 to the negative t. And when t equal to 3 seconds, so when t equal to 3 seconds, we're just gonna plug into this equation. The acceleration is gonna be equal to 60 times e to the -3. So that is 2.99 feet per second square. Okay, that is the second question. Any question? Okay, so we can go to the next one, but seems I forgot to put one question on here. Let me see. That is third one or fourth one. Okay, the third one is here. Have to make this one smaller. So for this one, again, is a particle moving by the relation. So we have the acceleration is actually a function of the displacement. So that is the displacement, acceleration A equal to -k over x. And the k here is already mentioned on, there it is. K is actually a constant. Okay. So the k is a constant and it's also a unknown. And the x on here is a variable, it's just the displacement. And the acceleration is a. So just gonna write down the given condition. The velocity, when the velocity is 15 feet per second, we know the displacement at that time gonna be 0.6 feet. And when the velocity is at 9 feet per second, the displacement is equal to 1.2 feet. So they're actually here and here. So the question is, find the velocity when x is equal to 1.5 feet. And the second one is we're going to find the displacement when we know the velocity is equal to 0. So it's like we have an equation here, but this equation is not a full equation. We have like an unknown value here. So, but like we also have some condition, like a known condition over here. So the first one we want to know is we want to find out what's going to be the actual value of the K on here. So it's like after we find out what is the value of K, we have the full equation, and then we can use the full equation here to solve our first and the second question. So our first step is finding what's going to be the value of the unknown K. So find unknown K using the known condition. So let's see on here, we have the relationship between the acceleration and the displacement. And then we can go back to our, cheat sheet, to our formula sheet. An equation that is like relating the acceleration and the displacement is actually this one. Like we have the acceleration here, we have the displacement here. And we also like VDV on the other side. So like we can try if this equation gonna work. So I'm going to put this A ds is equal to VDV, and like we can just do the integration on both sides. So on the left hand side, it's gonna be S. So the displacement here is actually X. So we can know like from here, I'll just put the 0.6 as the lower boundary and the 1.2 on the top as the top boundary. So on the left hand side, we're going to evaluating from 0.6 to 1.2 ADS. And on the other side for the VDV, like they need to be connected. Like when we put 0.6 on the bottom side, the velocity need to be the corresponding velocity. So we need to put the 15 on the bottom side. Like these two should be in a pair. And when we put 1.2 on the top boundary on the left hand side, the right hand side, like the top boundary on the right hand side should be 9. Should be this one. Okay. And next one, we're just gonna put down like put in the equation for them. So on the right hand side, we don't need to do anything. It's just gonna be VDV. VDV. But on the left hand side, we know the acceleration is actually a function of displacement. So that is gonna be negative K over X ds, or because I'm using S here, it's gonna be like this. And like next one is just gonna be solving this equation. It's just gonna be purely math. So on the right hand side, the integration of V itself is gonna be half V to the power of 2. And we're going to evaluate it from 15 to 9. Yeah. And on the right hand side, the integration of this one is gonna be negative K. So the integration of 1 over S or like 1 over X is gonna be ln S. And we're gonna evaluate them from 1.2 to 0.6. Okay, so I'm just gonna like plug in the value and solve this equation. So on the left hand side is negative k log 1.2 minus 0 log 0.6. And on the right hand side, that is going to be half 9 square minus half 15 square. Let me see. On the left hand side, it's like this. Okay, so we're just gonna put in like everything into a calculator. So right hand side is minus half to the power of 2, and right hand side like gonna be log 1.2 minus log 0.6. Like I'm moving this negative value to the right hand side. So like 15 is gonna go to the left and 9 gonna go to the right. So just use a calculator to do that. And we're gonna have k is equal to 103.874. So the unit actually doesn't really matter on here because it's just like a constant, but like I'm still gonna put them there. So now we have k. So after we have the k, we can finish the equation on the top. So we know a is equal to negative 103.874 over x. So that is the full equation between acceleration and the displacement. So now we can solve the first small equation, for first question. Where, let me see. Find the velocity when x equal to this value. Okay, so we're gonna use the equation on here just repeatedly to find out the equation. So like we're just gonna like set up the equation here. Okay, let me see. When x is equal to 1.5. So we're just going to evaluating from 0.6 to 1.5 ADS. The 1.5 is actually over here, so we're just gonna put them on here. And this one is gonna be equal to the right hand side when the displacement is equal to 0.6. We know the velocity is equal to 15. So gonna keep the 15 here. And we're looking for the velocity, like what's gonna be the corresponding velocity when the displacement is equal to 1.5 feet. So this one is gonna be the unknown value, or like the value we are going to solve for. And like next one is just gonna be like solving the equation like before. So on the right hand side is the same, half v squared evaluating from 15 to v, or like v naught. That is like, I mean, the unknown we are going to use solve. And on the right hand side, it's going to be log x evaluating from 0.6 to 1.5 and times k. Right, the k is already on here. So the next one is just like using the calculator, punching the value and get the solution. On the left hand side, we know K is well, missing a negative sign here. It's negative 103.874 times ln 1.5 minus ln 0.6 equal. So the left hand side, if you use a calculator, that is gonna be equal to 95.18, and on the right hand side is half v squared minus 112.5, and we have the velocity is gonna be equal to the square root of 34.64, and that is 5.89 feet per second. So that is for the first question. Like essentially, we're just gonna using this formula, like again, just like reset the boundary, and then solve for the value we're gonna need. So that is the first one, and the second one is basically gonna be the same. The second one is we know the velocity, we're looking for the displacement. So like the equation is not gonna change, just the boundary gonna change a little bit. So in this case, we're gonna evaluating from 15 to 0. On the left hand side, it's gonna be from 0.6 to the value that we are looking for. So this one is the unknown. So that means when the velocity is at 15 feet per second, we know the displacement is at 0.6. And we're looking for when the velocity is at 0, what's gonna be the displacement on here. So on the right hand side, just gonna be the same thing again. Half v square, evaluating from 15 to 0, and on the right hand side, also the same thing, x from 0.6 to x naught. So on the right hand side, like 0, put the 0 into the v, it's gonna be 0. So eventually it's gonna be 112.5 negative. And on the left hand side, that is gonna be negative. Just put in the k value, 103.874 ln x naught minus ln 0.6. Okay, so I'm just gonna move this value to the right so that we have ln x naught minus ln 0.6 is equal to 1.083. And gonna use a small trick over here, like ln x naught minus ln 0.6 is equal to ln x naught over 0.6. That is equal to the same thing. So x naught over 0.6 is gonna be equal to e to the power of 1.083. So x naught, that is gonna be equal to 0.6 times e to the power of 1.083. So just use a calculator, you can find out the answer is 1.772 feet. Okay, so that is for the third question. Do we have any question? Nope. Okay, good. Okay, so we're gonna go to the fourth one, but I forgot to put them on here. So they're actually very similar to the third one. Gonna write it down on here. Or like you can also find them on your Brightspace. So what we have is a equation again, uh, relating the acceleration and the velocity like before in the third question. What we have is a equation relating the acceleration and the displacement. But now we have an equation relating the acceleration to the velocity. So the known condition is like for this one, going to be the same. K is the constant and it's unknown value. No constant. V is the velocity and A is the acceleration. So the given value is when the displacement x is equal to 0. At that time, the velocity is equal to 81. And also we know at that time, it's just like at the very beginning, so the time t is equal to 0. And when the particle keep moving, so when the displacement is equal to 18, the velocity actually decreased to 36. And we don't know what's gonna be the time at this moment. So the question we need to answer is when the acceleration, I mean, when the displacement is equal to 20, what is gonna be the velocity? And also when the velocity is equal to 0, like when the particles stop, how long do we need to wait? What's gonna be the time? So also the first thing we need to find out for this question is the unknown value, the K. So we're gonna use the given condition to find out what is the K on here. And pretty similar to the previous one we have, we're just gonna use the BdV equal to AdS. We're gonna use this one. So on the right hand side, we know what is A, or like we partially know what is A. So A is equal to negative K times square root of velocity V, ds. And on the left hand side, it's not gonna change. So I'm just gonna like reorganize this equation. I'm gonna move the square root of V to the left hand side. Then we can get square root of V dV is equal to negative K ds. And then now, like here, I'm gonna do the integration on both sides. So on the left hand side is dV, on the right hand side is just gonna be ds. So going back to the condition we know, like we know when the acceleration, I mean, when the displacement is at 0, the velocity is at 81. So we put 0 on here and we put 81 on the other side. And we also know when the velocity is 36, the displacement is 18. So displacement goes here and the velocity goes here. Okay, so we have the integration set up. What we need to do is just solving this equation. So on the right hand side, since k is a constant and the constant is not like related to the s here, we can just move it out of the integration sign. So that is going to be negative k and s, like we're integrating one ds. So it's like we're doing this, negative k ds. So like doing this means like integrating one. So that is just gonna be s itself. So it's evaluating from 18 to 0, and on the left hand side, the integral of square root of b is going to be e to the power of 3 over 2 times 2 over 3. And we're going to evaluate in this one from 81 to 36. I mean, from 36 to 81. So on the right hand side, it's going to be 0 minus 18k. So that is going to be positive 18k. On the left hand side, just gonna be like putting the number into the equation, minus 36 to the power of 3 over 2. So we have 18k on the right hand side, and use a calculator to solve for the value in the bracket. That is going to be 513. So eventually we know k going to be equal to 19. So now we have the k on here. I'm gonna make this one smaller. So now we solve for k, and the next one we're going to working on is question A and question B. So for question A, we know the displacement and we are looking for the velocity. So basically we're gonna use the same thing. A, k is equal to 19. Gonna write it again on here. K is equal to 19. So just setting up the equation again. On the left hand side, integrating square root of b. On the right hand side is going to be negative k integrating ds, and then we can put a boundary. Let's see. Okay, so since we're looking for the velocity when the displacement is at 20, I'm gonna put a 20 on here. And the velocity is a value that we are looking for, so I'll call it V0. And the lower boundary, just gonna copy the thing from before, from here, like when the velocity is equal to 36, the displacement is equal to 18. So 36 and 18. Okay, so we're back to solving the math again. So the right hand side, we know k is equal to 19, so negative k is negative 19, and times s, evaluating from 20 to 18, from 18 to 20. And on the right hand side, just going to be the same thing. evaluating from 36 to V naught. So on the right hand side, we're just gonna put in the value that is negative 19 times 20 minus negative 19 times 18. And on the left hand side, like put in the value V naught to the power of 3 over 2 minus 2 over 3 times 36 to the power of 3 over 2. So the bottoms are going to be negative 38 times 3 over 2. And the 11s are going to be V naught to the power of 3 over 2 minus 36 to the power of 3 over 2. Like I'm just solving the equation here. And V naught moving this one to the right hand side and put them into a calculator. We can get V naught is like V naught to the power of 3 over 2 is equal to 158, 159. And then we have V naught equal to 29.3 meter per second. Okay, so that is for part A. And for part B, for part A, we're just gonna like repeatedly using this equation to find out the value. And for part B, we actually gonna use something different because it's like the equation we know, like equation we use, this one is about the velocity, about the acceleration, about the displacement. But like in part B, we're looking for the time t, and the time t doesn't appear in this equation. So in this case, we need to find out another suitable equation to do that. And we can go back to our formula sheet. Where it is, that's here. So what we know is the acceleration, the velocity, and we're looking for t. So we need these three values in one equation, and the one actually we have is this one. So acceleration is equal to dv over dt. And that is the one we're going to use for part B. So just copy down our equation between velocity and the acceleration. A is equal to negative 19 square root of b. And equation we're gonna use for this one is A equal to dv over dt. Just gonna be reorganized this one, like putting the dt to the left hand side. A dt gonna be equal to dv. And then we can set up the integration. So on the left hand side, that is gonna be A dt evaluating dt dv. And we know A is a function of velocity, so that is negative 19 square root of t, square root of b dt. And on the right hand side, just going to be dv itself. So here we need to set up the boundary. We can set up the lower boundary first. So we know that on the known condition on here, let's see. Velocity. Okay, so we are looking for when the velocity is equal to 0 and what is going to be the t. So here, well, actually, I'll put them on top. And the velocity is equal to 0. We're looking for T naught. So that is the unknown value we're looking for. And for the lower boundary, we just need to like use another known condition. Also, in this case, we can have when T is equal to 0, the velocity gonna be equal to 36. Okay, so we set up the equation, and what we need to do is just like solving the equation. So on the right hand side, we're gonna move the square root of v to the right hand side. So that is gonna be 1 over the v dv. And on the left hand side is 0 to t naught negative 19 dt. So the right hand side, like doing the integration about that, is actually 2 square roots of v, and going to be evaluating from 36 to 0. And on the left hand side, seems like here we only have a constant over here, and it's also evaluating from 0 to t naught. So it's gonna be pretty straightforward. Just gonna be negative 19 t naught. Then we just need to put in the number. Left hand side is not gonna change. Right hand side is gonna be putting a 0 here and then minus the other one, so that is gonna be negative 18. And then we have a t naught is equal to 18 over 19. So that is 0.947 seconds. Okay, so that is part B. So essentially, we're just gonna use another equation, and then we set up the integration, and we found the boundary, and then we solve for the equation, and we get the answer. Sorry. Let me see. So that is 2 times square root of v, and you put 0 and 36 in there. So it's like when you put 0 there, it's oh yeah, it's minus. Yeah. Yeah, I need to come here. I'm just correcting the math on here because I put a wrong thing over here. Like this one should be 81. Like when the velocity is equal to 81, the time is 0. So where it is? Also here. Yeah. When the velocity is 81, the time is 0. Going back on here, 81, gonna put the 81. Like everything should be 81. And on here, it's gonna be different. 2 times this one minus 2 times 31. Okay, so it's negative 18 again. Yeah, so wow. So like the final answer is not gonna change. Oh, okay, so let's go to next one. We finished question 4. Okay, so next one is question 5. Question 5 is over here. So in question 5, again, we have the equation between the acceleration and the time t. And we also have an unknown constant k over here. Unknown constant k over here. And I'm gonna write down the known and the unknown condition first. So the known condition first. A is a function of time t minus 1.44 cosine kt. And we also know the k, okay, the k is actually given as 3 rate per second. And it's over here. And we also know that when the displacement x is equal to 0.16 meter, the velocity is equal to 0.36 meter per second. And that is at the very beginning, so t is equal to 0. And the unknown, that is the one we're looking for, is we're looking for the velocity and the x when t is equal to 0.5 seconds. Okay, so that is the thing we're looking for. So now we need to find out a equation that is suitable for solving this question. And what we have on here is acceleration, and we have t, and also we know the velocity. So we have a, we have v, and we are looking for t. And then we can go back to our formula sheet. We have velocity, we have acceleration, and we are looking for t. So that is the one we're actually going to use. So back on here, we have a is equal to dv over dt. And just rearranging this one, we have dv is equal to a times dt. So based on this one, we can set up the integration. On the left hand side, the integration is gonna starting from 0.36 to velocity dv, and that is equal to okay, I'm not gonna put the boundary first. We can solve for the boundary later. So on the right hand side is actually gonna be integrating a dt, and the a is a given value, so that is negative 1.08 sine kt minus 1.44 cosine kt dt. Okay, so we have the equation and we're going to set up the boundary condition. So when the time, oops, when the time is equal to 0, it's actually on here. When the time is 0, we know the velocity is 0.36 here, 0.36. And when the time is equal to 0.5, we're looking for the velocity here, this one. It's gonna be V naught. Okay, so the next one is just gonna be like solving for this equation. So what we have on the left-hand side, since we're like integrating 1, so that is gonna be just gonna be V naught minus 0.36. And on the right-hand side, we can do them like separately, first one and the second one. For the first one, we have like integrating sine kt is gonna be 1 over k, actually gonna be negative 1 over k, sine kt times negative 1.08. That is gonna be evaluating from 0 to 0.5. And then we minus the integration of cosine kt is gonna be sine kt. It's sine kt, yeah. But actually 1 over k times sine kt and times 1.44. Evaluating also from 0 to 0.5. And then we're just gonna simplify the equation we have on here. So on the left-hand side, everything gonna stay the same. On the right-hand side, that is 1.08 over k times sine kt. Also evaluating from 0 to 0.5 minus 1.44 over k sine, wait, this one should be cosine. Yeah. For sine kt, also evaluating from 0 to 0.5. Okay, so the right hand side is just gonna be 1.08 over 3, like I'm plugging when k is equal to 3 on here. Cosine 3 times 0.5 minus 0. Shouldn't be like this. That should be 3 times 0.5 minus cosine 3 times 0. And minus the second term, 1.44 over 3. And that is sine 3 times 0.5 minus sine 3 times 0. So again, just solving the math. So what we are going to have is this one 0.36 cosine 1.5 minus 0.36 times 1 and minus 0.48. So 0.48 is 1.44 over 3 times sine 1.5. And sine 0 is 0, so we don't write it down. And what we have is V naught is equal to 0.36 cosine 1.5. And the middle term gonna cancel out with this one, just minus 0.48 sine 1.5. So solving this one. So one thing keep in mind is like in the question it says the 1.5 and also the 1.5 here are actually in radians. So we're actually solving cosine 1.5 rate, but not cosine 1.5 degree. Like when you're punching the value into your calculator, you must make sure your calculator is calculating 1.5 radians, but not 1.5 degree. Like I remember for like most of the Casio calculator, when you say like cosine 1.5, it's gonna calculating the 1.5 cosine 1.5 degree, but not the 1.5 radius. So you have to convert the degree to the radius and then do the calculation. I mean, you need to convert the 1.5 radians to 1.5 radians to the degree and then put it into your calculator and find the value. So those are the radians. And then using the radians, you can get the final value that is 0.45453 meters per second. So that is for, well, actually we have another one. So that is how we find the velocity. So we solve for this one, and next one we're gonna solve for the displacement. So again, gonna be very similar. We're just gonna set up another equation, keep solving the integration, and then do the math, and then we can get the final answer. So for this one, you're going to use the velocity because we're looking for the displacement this time, right? We're looking for the displacement this time. So the main equation we're gonna use is the velocity is equal to ds over dt. And this one we can simplify, not simplify, but like we arrange the equation to d dt. And so now we need to have a equation between v and t. And the equation between v and t is exactly what we got in on here. Like it's going to be this one, or like going to be this one. So we're going to use this thing we found previously into this one, and then we can have the s, that is a displacement, is equal to from 0 to 0.5 v dt, because the time boundary is from 0 second to 0.5 seconds. And for the velocity v here is another function, like gonna be evaluating from 0 to t of a dt. So like they are one group and the rest are the second group. And like everything to the orange box are the equation we already solved in our first part. So like for here, I'm just gonna copy everything down from the top. like in the orange box. So this case is gonna be 0.36 cosine kt minus 0.48 sine kt dt. So like the orange box are the solution we found above. And then we just need to evaluate this one from 0 to 0.5. So again, it's a math question. And the integration of cosine kt is going to be sine kt, or I mean 1 over sine kt. 1 over k times sine kt. Sine kt times 0.36. And the integration of negative sine kt is going to be cosine kt. 1 over k times cosine kt. So it's going to be a plus 1 over k times cosine kt times 0.48. And everything gonna be evaluating from 0 to 0.5. Like those are the blue box. So we also know the k is equal to 3. So what we have is 0.36 over 3 sine 3t plus 0.48. That is 0. Okay, I'll just write it down. 0.48 over 3 cosine 3t, evaluating from 0 to 0.5. So 0 is just 0, so you can use a calculator to do the math. 0.16 cosine 3 times 0.5. And that is going to be 0.131 meter. S. So now we find out what is the value of S. Then the time t is equal to 0.5. So that is for the fifth question. Okay, so let's go to the last one. Actually, the last one is, I guess it's easier. So going back to my note. Here's my note for the last question. 6 here. So again, I'm gonna draw a diagram for this one. So from point 0 to point 1. Like in between that is 16 yards. And usually we need to like change the unit to feet. Like for the empirical unit, we need to change it to feet. For the SI unit, we need to change it to meter. So 16 yards is 48 feet. And the second segment is 24 yards. Sorry. You don't really have to, but like if you don't, if the question gonna be like very long and like in the like later you're gonna have some more like calculation, you wanna like change it to yeah to fit. Like if the question is very short, you or like I remember like later you guys gonna learn some like about kinematic like those energy equation. Like if you wanna use those energy equation, you have to use like either feet or meter. Okay, so 24 yard is 72 feet. And let's say that is T1 and that is T2. So it says T1 plus T2 is 4.25 seconds. And that is 16, let's see, that is 0, that is, then we know, okay, let's see. From the question, we know the acceleration is a constant. So that is very important. Means we can use the easy equation from high school. And it's gonna reach the fastest speed on here. So let's say the velocity at that point is just v. So for the first, from 0 to 1, can say the distance s or 48 feet is equal to half 80 square. So gonna be half times the acceleration. That is the first unknown we have times t1 square. And also for the second, from 1 to 2, we know the length, what is this? 72 feet is equal to the velocity, the fastest velocity times t2. So velocity is also a unknown value. And for the unknown value velocity is equal to a times the acceleration times the t1. So we have a set of equation, and let's see. We have one equation, we have two equation, we have three equation, we have four equation. Now how many unknown we have? We have one unknown t1, we have t2, t1, t2. We have acceleration a, and we also have the fastest velocity v. So we have four equation. We also have four unknown. That means this matrix or like this set of equation is solvable. So like they're just gonna be purely math. And if you solve everything, the answer gonna be like just solve this formula. T1 is equal to 2.43 seconds. T2 is 1.82 seconds. The acceleration is 16.28 feet per second square. Velocity is 39.5 feet per second. So those are the set of answer for this question. Okay, so that is all the questions.